Okay, hey, ladies and gentlemen, welcome to week 1, day 5, right? That's what, yeah. Okay, week 1, day 5. Mr. Roll is back here again with Miss Lee, our 4th and 5th grade teacher. And we are here to do some announcements and then tell you a joke. So, first announcement, today is day 5, which in a normal week would be Friday. And so that means that you will have you will actually have a little bit of homework, okay? So kids, don't just turn off your videos and throw your iPads on the ground and start screaming, okay? We're still gonna give you just a little bit of homework over the weekends now, because when we're not sitting together in the class, we kind of have less time to do work together, okay? If you are not from Da Vinci Tree and you're wondering why some other kids might be mad right now, at Da Vinci Tree, we never do homework on Fridays. Okay, but because we're switching over to this system, your teachers have been given permission to give you homework. So hate me, not them. I have given them that permission just so we can keep things rolling with you guys. So that's our only announcement for today. Let's go ahead and turn it over to Miss Lee for our joke. Go ahead, Miss Lee.
Thank you. All right. How does a Pokemon sneeze?
I don't know, Miss Lee. How does a Pokemon sneeze?
Pikachu!
Get it? Because it's a Pikachu?
Yeah.
Okay, I like that one. You should be laughing. Okay. All right, Miss Lee, go ahead and let's do the pledge.
All right. Everybody please stand at attention. Hats and hoods are removed, and place your right hand over your heart and follow after me. I pledge allegiance to the flag of the United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
All right. Thank you very much, Miss Lee. Let's go ahead and get to our classes. See you guys in a bit. Thanks.
Have fun.
All right, I think it's recording. Hey, Mr. Barbero. Hey. Okay, so, ladies and gentlemen, let's go over the agenda for this week. For this day. Now, the agenda is the same every day, pretty much. So, we'll just run down the list. We have our life skills first from homeroom. Then we do social studies, starting with current events, and then moving on to history. Then we do, usually our literature comes next. And we have our science, and we have our math. Okay, so that's pretty much it. It's the same as we do, I think, like every day. But for the life skills, you have another talk. Social studies, another talk. For literature, we're going to be doing something a little different coming up here. I'm going to save that for lit. In our science class, it's more about basic physics. Again, we're trying to break these concepts in physics down. I know I'm actually a little bit concerned that we're making it too simple and we're not capturing like what it actually means, but we'll keep on doing this, and if you can follow along with what I'm saying, even if you don't get parts of the videos that we're showing you afterwards, I think we're doing okay. So yeah, what do you think, Mr. Barbero? Yeah, sounds fine. So, and then finally for math today, Mr. Barbero is going to be reteaching everything that we've learned this week as a good review. If it works, then moving forward we might be doing that. I'll teach 4 days and then you do a review on Friday or day 5. Sound good, Mr. Barbero? Sure. Okay, he's over there. I don't know if you can hear him. All right, let's go ahead and get started with life skills. All right, it's really nice out here today, and it's beginning to sprinkle, so I thought I'd shoot a little bit out here before I have to go inside. For today's life skills, I wanted to talk about the concept of paradox. A paradox is something that seems like it shouldn't exist. It's contradictory in nature, but in reality, it describes a great truth. So paradoxes are everywhere. They're in everyday items. A very popular example of a paradox is the idea of jumbo shrimp. how can you be both jumbo and still be a shrimp, right? And so people say that that's paradoxical. In life, we can be paradoxical. It's a common saying that you always hurt the ones that you love. So if you love them so much, why are you hurting them? It's paradoxical. It's things that sound on the face of it to be utterly contradictory, but it is a truth. And so I think you can probably hear the wind behind me and a little bit of the rain, so I'm going to go in a second. But I want you to think about things in your life that are contradictory. What things in your life contradict themselves and yet still exist? Maybe you hate reading, but you love reading comic books. Maybe you have trouble focusing, but it's really easy to get into your favorite television show. What things in your life are paradoxes, and why? So today, for your life skills homework, I want you to take a few minutes and think to yourself about yourself and see if you can come up with any paradoxes in your own life. All right, well, I'm gonna head inside before I get drenched here. But yeah, I think I like being outside. I think we're all cooped up inside a little bit too much these days, so I might do a few more of these later. Thanks. Okay, I think we're recording. All right, so today we are in, let's see, can you guys see this here? How high can I go? Good. All right, so we're still in week 1, day 5, and this right here, we're talking current events. I think it's a little hilarious how I teach current events with you guys, and then I end up having to go back in history to explain things. But the reason for that is that the world around us today can best be understood through the lens of things that have happened in the past. So if you truly want to understand what is happening in the world today, again, you have to go back and understand the way things were in the past. So that is why we are doing what we're doing. Okay, so y'all know we've been going over this every day now. We've been going over contractions and expansions. So we are not really focusing on expansions. We're mostly focusing on economic contractions because that is the phase that we are most likely going into. Okay, as you recall, we have 2 basic kinds of contractions here. We have our recessions and depressions. So a recession is not desirable, but it's still not terrible. Okay, I used the example the other day, if you have to get sick, catching a cold is not the worst sickness you could catch. Okay, there are much worse sicknesses. And so a recession, while not being desirable, is a normal part of life. Contractions are a normal part of life, and a recession is not the worst thing that could happen. Now, I have heard about people saying, well, not all contractions are recessions or depressions. Some contractions are so mild that we don't count them as a recession, and that's okay. In previous days, we talked at some length, and I tried to explain that this concept of a recession or a depression is so complicated that people literally spend a good portion of their life writing about it and what it means. And so we don't want to get into that level of complexity, guys. We just need to understand the basic concepts, okay? So again, when we talked about recessions, we have businesses in the community, the economy is shrinking for an extended period of time, and the unemployment rate is approaching 10%. For depressions, businesses are shrinking for an extended period of time, and the unemployment rate is at or reaching 30%, okay? So depressions are really bad versions of recessions. Now, I want to build on what we talked about yesterday. I didn't write it on the board, but all expansions come to an end because of a problem, okay? So when an expansion comes to an end and we go into a phase of contraction, that happens because of a problem. The phrase that I used yesterday or the day before, I don't recall, was expansions do not die of old age. Expansions do not die of old age. Theoretically, the economy could continue growing for an indefinite period of time. So our businesses, our economy, they could continue expanding for an indefinite period of time, but problems always happen. So today, I want to talk about and put up on the board some of the kinds of problems that cause a contraction, okay? So, contractions are caused by problems. Let's discuss problems that cause contractions. How far over? Okay, I still have plenty of room. Problems that cause contractions. So, the big problems that cause contractions, the problem today that's giving us a contraction is very obvious, okay? Disease. So one problem that can cause an economic contraction is disease. Disease has caused contractions in the economies of human beings for many years, okay? A lot of people are talking about the Spanish flu from 1918 today. Some people are talking about the Black Plague that hit Europe many years before that. And so disease is one cause for an economic contraction, and that's normal, okay? Now, all of the other causes of economic contraction are man-made, pretty much. Not all of them. We have disease, we also have natural disaster. Frankly, a disease is maybe like a kind of natural disaster, okay? So we have disease, we have natural disaster. Okay, war. War is another thing that can cause a contraction, okay? Now, here's the weird thing, and we're not going to get into this today. War causes contraction, but the aftermath of a war can help spur on an expansion, okay? So war itself does not cause expansion, okay? I've even heard some adults say this, like kids say it all the time. But I've heard adults actually say, well, if we are in a recession, we should go to war because that will put us back on the right footing. That's not true, okay? War does not cause expansion, quite the opposite. The aftermath of a war, though, has the possibility of creating an expansion, but war itself does not cause an expansion, okay? So war causes contractions. Other things that cause contractions, again, war is man-made, and the other reasons for contraction are also man-made. Okay. Trying to think of a good way to put this. Irresponsibility. Irresponsibility causes contractions. People who are being irresponsible. Irresponsibility. I'll say irresponsibility with money. Okay? People who are being irresponsible with money can cause a contraction. Another thing that can cause a contraction is an imbalance of trade. A trade imbalance. Okay? Trade imbalances can also cause contractions. And so, for today, I'm going to leave this lesson at this, okay? These are some very common causes of contractions. Disease, okay, we already talked about natural disasters can absolutely cause a contraction in an economy. Before this all happened in history class, we were learning that the United States around the time of the Civil War was getting a lot of immigrants coming in from Germany and coming in from Italy, or not Italy, I'm sorry, excuse me, Ireland, because those countries were in the middle of a contraction because of bad weather. We had the potato famine and we had a really severe winter in Germany, and these natural disasters were giving them an economic contraction, and so they had to move or starve. War causes economic contraction. We see that all the time. Right now, today, they're having a giant economic contraction in the nation of Syria because they are at war, a war that won't end. And so that's causing a lot of pain and suffering and economic contraction there. Irresponsibility with money. This is a key one for most American contractions, okay? The contraction, the Great Recession of 2008 was caused by irresponsibility with money. To a great extent, the Great Depression in the United States and the world was caused by irresponsibility with money. So this is a big one. That's a very generic term for it. And then lastly, trade imbalances can cause recessions as well, which is something else that we'll talk about later. So yeah, that's it for today's current events. Day 5, week 1. All right, so the Gettysburg Address. The Battle of Gettysburg was a very bloody battle, and it was an important battle in the war, both because of the gore and because it was a victory for the North. Okay, and so this battle happens. It was really bad, and then about a year later, give or take, the grounds of Gettysburg were turned into a memorial. And at that memorial ground, they put together a giant event to dedicate the memorial at the grounds of Gettysburg, both as a kind of a sacred and holy place, as the final resting place for so many American soldiers, but also as a memorial of a Union victory. And so the Gettysburg event was scheduled, and they had several keynote speakers. And 2 of the keynote speakers that were most notable were the governor and Abraham Lincoln. And so the day before the Gettysburg Address was to be given, and the event at Gettysburg, Abraham Lincoln got on a train and he set out to the memorial. And there are conflicting reports, but by and large, people believe that he wrote the Gettysburg Address on the train. Now, if you've forgotten, a political speech back in the 1860s and 1850s, political speeches where they were almost like entertainment events. If you go to a movie today and you pay for a ticket and you sit down with maybe your friends or your family, you expect the movie to be like an hour and a half or more. If you sit down for a movie and it's only 45 minutes, you feel like you got ripped off, right? And so back then, when people would go to these political events and these ceremonies, usually they would be an all-day affair. And so most of Lincoln's speeches lasted 2.5 to 3.5 hours long. And so the people at the event were numerous. I don't remember how many. Sorry, and I'm not going back and rereading everything before presenting this to you guys in many cases. I apologize for that. But there were a lot of people gathered there, and Lincoln was up at the front with the governor, and so they were, and so the event began. Now the governor went first, and the governor's speech was excellent. The governor's speech lasted for well over 2 hours. And in the speech, the governor, he basically gave a summary of the Civil War. The governor went on and he had a lot of applause. People were standing and cheering for him as he talked about why the Civil War was being fought. He extolled the virtues of American leadership in Lincoln, okay? And he gave a complete and really thorough, well-reasoned history of everything that had happened. It was an excellent speech. And when the governor was done, Abraham Lincoln rose to stand. And again, everybody had expected a 2 to 3 hour speech from the governor and another 2 to 3 hour speech from Lincoln. And so Lincoln stands and he gets up on stage, and out of his coat pocket, he takes one single sheet of paper. And he gets up at the lectern or on stage at the podium, and he unfolds this piece of paper. And in his very loud, very high-pitched Lincoln voice, he begins to say, 77 years ago, our fathers brought forth upon this continent a new nation. And he went on, and he gave this speech, which did not last 2 hours, which barely lasted 2 minutes. And at the end of the speech, he looked around at everybody, and he folded up the paper, and nobody cheered. because his speech was so good, but so short, that nobody knew that it was actually over until he put the paper back in his coat, or I don't remember if it was his hat or his coat, and he began walking away. And it was only when he began walking away that everybody was like, oh, that's it. That's the speech. And uproarious applause. Everybody stood, and that speech, that short speech, basically not even a speech for that period of time, that speech became the clarion call for the rest of the war. Every school child and every soldier, every person in America, even people who couldn't read, heard that speech and memorized that speech and could recite it from off the top of their heads. I would very much like those of you who are in my class to try to watch the Steven Spielberg movie, Lincoln. It is very well done. Steven Spielberg went through great pains to make Lincoln and Henry Seward and the entire cast of people, Ulysses S. Grant. He tried to get the actors to really embody the actual character that they were playing. He did a great job. And in the beginning of that movie, there are some soldiers, some African-American soldiers who are expressing their gratitude to Lincoln. And as they're walking away, they're reciting back to him the Gettysburg Address. And so that is kind of the story of the Gettysburg Address and why it was so wildly popular back then. And to this day, echoes as the most memorized speech in American history. 1, it's beautiful and profound. 2, it's real short. Thanks. All right, ladies and gentlemen, we're in literature now, and it is week 1, day 5. So, yesterday you should have read the chapter, what's it called, from Cape Horn, to the Amazon. In that chapter, they break free of the South Pole, and as I recall, they're all very happy for, having air, right? And so they start heading back up north away from the Arctic Ocean, and they're trying to figure out where they're going because they all want to escape. And this whole experience kind of binds these 3 friends together closer than they ever have been. And basically they're all like, we're best friends forever now. Yeah, nothing's ever going to stop us from being friends. And then Ned Land is like, that's right. And when I run away, you got to run away with me. No more, wavering about this. And so as they're heading north, they discover that they are heading, I think, towards the Atlantic. And so they're going up the coast of South America. And so when they get to Brazil and they hit the Amazon, they kind of stop there and they camp out and they do some fishing, and not too much else happens. Was it Conceal? I think he gets like stung or bitten or something. And then, if I recall correctly, he eats the fish. He finds the fish that bit him, and he eats him just out of spite, which I thought that was funny. And so that's pretty much it. I think that's how that chapter ends. Okay, so for tonight, let's see. What is the name of the next chapter? I forget. Oh, yeah, okay. Wait, is that the next one? I thought there was a chapter in between. Okay. Tonight, you have to read the chapter entitled Squid. This is one of the best chapters in the book. And if you've ever seen the movie or any of the movies that they've made, this is like a key theatrical scene in all of the movies. So your homework for tonight is to read the chapter Squid. Yep. Okay, welcome to day 5, week 1 of science class. So, when all of this broke out last week and we decided to go online and we had to change our plans like 2 or 3 or 6 or 7 times, I had Mr. Barbero and I meet. We both sat down and we both thought it would be a fun idea to do science lessons on mechanical advantage, and there's some fun demos that we could have done together. But since then, 2 things have changed. 1, it's becoming increasingly possible that we are going to be locked down, and so Mr. Barbero and I are not going to be allowed to hang. therefore taking away the fun that we were planning on having by setting up mechanical pulleys and things like that to videotape for you. Because, I mean, really, when do two grown men have an opportunity just to hang out as buds and make dumb videos when they have, like, jobs and families to support? Not often, so we were looking forward to that. But the second thing that changed is as we started teaching it throughout this week, I realized that we don't really have the fundamental science like background yet to start talking about some of these bigger concepts. So I'm actually going to roll it back a little bit. Instead of talking about work and watts and joules and how that all works together, we are going to take a step backwards and we're going to talk about the basic fundamental underpinnings of like pre-physics that allow you to understand those concepts more clearly. Because I was really struggling on making everything simple enough where you could understand those things without me using a bunch of science terminology, and it's really hard, and again, everything's less fun because we probably can't make pulleys. So again, we're just going to rewind, and so today's science lesson, we're taking it all the way back to talk about force, the scientific concept of force. And so we talked about work a little bit, okay? But today, I can't do that. Today we're going to talk about force. And so force in physics is a push or a pull that acts on an object. That's simple. Force is just a push or a pull. That's it. And it's a simple idea, but I need you to remember it. And so in order to get you to remember it, we're going to watch a little video together. Now, to be clear, I actually like this video and I like the guy in the video, but we're going to watch it sarcastically together because you're preteens and I think that's what you do best. So let's watch the video sarcastically together. By the way, it says this is for kids. I think it's for very young kids. And this Kids Academy thing is actually pretty cool. If you have any younger brothers or sisters, I highly recommend that you watch it with them. But again, push and pull are forces.
How about Polly?
Here's a grown man alone in his kitchen talking to a banana.
You know, push or pull on an object, like when I push this banana across the table, or if I pull it toward me.
What is a force?
That's a good question. What is a force? Let's talk about it. When an object moves from place to...
So kids, you might feel tempted to feel sorry for that man, but if you look back in the video, there was a purse on his countertop and a ring on his finger, so he has a wife and possibly kids because he's doing this. So kids, don't feel too bad for him. Again, this is the idea I want you to know. Force is a push or a pull
Now that
on
we
an
know a
object.
little bit about motion and forces, let's step into the lab and take a look at what they look like in real life using this toy truck.
And by lab, I think he means his garage.
And pull. So first what I'm going to do is I'm going to set the truck down, facing forward and backward. When I push it, I'm usually moving the object away from myself, so I can push it away from me.
I think that might not be his garage, because if it is his garage, I'm a little jealous. That garage is really nice. Probably is a basement.
Now I'm pulling the object. Now that's a forward and a backwards motion. We can do the same thing when we're talking about up and down. If I get under my object, like so, I can push the object up. Or I can set it down and I can come from the top of my object and I can pull the object up.
All right, all kidding aside, that is an important differentiation for push and pull on a force. You can push an object up or you can pull it up. Both of them have the same result, but the forces are very different.
The object will not move up by itself. Now I'd like to play a game where we look at real-life forces and determine whether they're pushes or pulls.
Yeah, we're going to play this game.
Force in action, you got to shout out whether it's a push or a pull.
Yay!
Spinning in first, we have an RV towing a car. Push or pull?
It's a pull.
Pull.
Woo-hoo! I got it right. Oh, by the way, tomorrow we're going to see that SUV on the right-hand corner get demolished. It's not the same video.
Next up, a game of shuffleboard.
Push.
That's a push.
Yeah.
What force am I using to roll this giant wheel? That's a push.
As you can tell, he has the same fashion sense as Mr. Roll.
Time for a tough one. This crane lifting a giant object?
That's a pull, guys.
It's pulling that slab. When we're playing pool, what force are we using? Push.
So what have we learned today? Objects don't move on their own. In order for an object to be put into motion or being moved from one place to another, some sort of force has to be acted upon it, either a push or a pull. So whether it's pushing a soccer ball with your feet or pulling your water bottle just a little bit closer, forces move our world.
So,
Again, this Kids Academy thing is really cool. If you have like a younger brother or sister, I highly recommend that you watch some of these cool videos with them. So, again, push or pull, those are forces. And so when we're talking about the word force or the concept of force in physics, again, it's either a push or a pull. Now, that kindergarten video is not the only thing that we're going over in science today. We need to talk about balanced and unbalanced push and pull, okay? So when we have a push and a pull that's acting on an object with another push or pull, we can have balanced or unbalanced forces, okay? So if I have a force that's moving in this direction, and I have another force that's opposing it, moving in this direction, if the two forces completely cancel each other out, so the one going this way and the one going this way, they meet, and they kind of keep each other at a standstill. We would call that a balanced force, okay? Conversely, if I'm not pushing, but if I'm pulling, okay, if I have a force that's pulling the cable this way and a force that's pulling the cable the opposite way, okay, if the two forces are pulling at the same level and they cancel each other out, that is a balanced force, okay? As you can probably imagine, an unbalanced force is when the two forces don't completely kind of cancel each other out, okay? So if you have a push moving this way and a push moving this way, and then they connect, and it starts moving this way, this push is stronger, and this force is unbalanced, okay? Same thing with the cable, and we're pulling, okay? If we're pulling this way, and we're pulling this way, and both forces are against each other, okay? And then all of a sudden this one starts winning out, this is an unbalanced force. All right, so we have forces, which are push and pull, and we have balanced, which kind of, they cancel each other out, and unbalanced, which make each other move, okay? Last thing we're going to do is we are going to watch just a couple of basic videos that illustrate this. Let me go ahead and bring that over. Where did I put those? You're looking at my messy desktop right now, probably. Yeah, you are. Oh, right here. Here's a good one. I love these videos from the Creative Commons. They allow me to use them however I want. So, this video is of a grown man who maybe, I'm not going to make any more comments. He's a grown man that just kind of plays with large vehicles as if they were toys and makes YouTube videos. So, I mean, you might love or hate it, but that's what he does. So, he has this Toyota truck, and he has this tiny Toyota car, and he's going to play tug of war with them, okay? Now, clearly, kids, this little tug of war game is an unbalanced game. That giant truck is going to completely wipe out that tiny Tercel. Okay, that's a Tercel, by the way, if you don't know. And so he starts wheeling them up here. Yep. And so that little Tercel, try as it may, it cannot beat that big truck. In fact, as soon as the truck gets going, boy, it just kind of rips it back, right? By the way, never do this to your car. You completely destroy the drivetrain when you do this to your car. It's really easy to break your transmission doing this. But again, this is an unbalanced force, guys. Okay? So, I gotta stop the video there. That's an unbalanced force. All right? The big truck is a lot stronger than the little car, and so it's a force of pulling. The two cars are pulling against each other. The big truck is big and strong. The little car is dinky, and so no matter how much that little dinky car pulls, it's an unbalanced force, and the truck's going to take it with it. Okay? To round out our video today, let's watch a balanced force. I have these funny office men, and I think this was also in the Creative Commons. I'm pretty sure that what these guys are doing is that these guys are trying to demonstrate, here let me pause it, they're trying to demonstrate the strength of this little floor panel right there. This is a business that sells floor panels, and that's why they unlocked this video so that people like me could use it in my videos. And so they're trying to show that this floor panel is really, really strong, but as they're playing tug of war, they're locked in a balanced force, okay? Neither side of these office workers is really winning out at first. And so right now, in this moment, the two opposing forces are balanced, okay? The men on the left and the men on the right are canceling each other out. So neither is really winning. And then the men on the right slowly begin to win. And as the men over there slowly begin to pull the other men, in fact, I don't know if this video is going to be inverted for you, but the guys who are winning over there are the stronger force. So it started off as a balanced force, and then the force became unbalanced, and then that guy showing you his hands is the loser, okay? And so again, today's lesson, very simple. Force is a push or a pull, and we can have balanced or unbalanced forces. That's it. I need you to remember that. It is very simple, and as we always say in class, sometimes the simplest things are the easiest ones to forget. So remember, force, push or pull, balanced or unbalanced. That's it for science today. Thank you for watching. Ooh.
All right. Hey everyone, I know it's been a while since many of you have heard my voice since I was out the whole week before our school shutdown. Sick myself. For those of you who have missed me, I've missed all of you as well. But we'll worry about that when we're all back together. For now, let's go ahead and do our quick math review for what you guys have learned this week. So we'll start with Group 1. So our problem for Group 1, our first one is going to be a review of your area of parallelograms. And our question is, Milo wants to find the area of the screen of one of the iMacs at school. He measures the screen to be 47 centimeters long and 26.5 centimeters tall. He calculates the area to be 1,235 centimeters squared. Is Milo correct? If not, what is the correct answer? All right, so for those of you who may have forgotten or just want a quick review, our equation to find the area of a parallelogram is A equals width times height. Okay, and in this case we have 47 for our width and 26.5 for our height. And these are both in centimeters. Okay, so all we have to do is multiply these two numbers together. So let's go ahead and do that. So we get 26.5 and that's not right. 47. All right. So we multiply this together, we get 5, 3, 42, 5 again. 14, 18, 24, 26, 8, 10, 5, 14, 2, and 1. And decimal goes here. Okay, so we got 1,245.5. And since this is an area equation and we use centimeters, it's going to be centimeters squared. All right, so the answer that we got, and also the correct one, is 1,245.5. If we go back to the problem and look, Milo had gotten 1,235. So Milo did get the wrong answer. I'm not quite sure what he did. I could spend some time figuring it out, but we're not going to worry about that right now. So this is the correct answer for that problem. So let's go ahead and forget all about all that. And let's move on to our review of triangles, areas of triangles. All right. So Gage calculates the area of a triangle with a base of 12 and a height of 17. He gets the answer 102 square units. Is he correct? If not, what is the actual answer? Okay, let's go over here to our other note where I can actually write. So, again, quick review of our formula for triangles. The area of a triangle, so A, equals 1/2 base times height. Okay, so if we go back over to our problem to get our numbers, we have a base of 12 and a height of 17. Okay, so we have a base of 12 and a height of 17. So we're going to multiply these two numbers together, and we're going to get what is that? 204? Sounds right. Let me double check. Yeah, 204. All right, so we got 204. Okay, so B times H, so these two letters equal 204, but we need half of this number, so we're going to put it over 2. All right, and then half of 4 is 2, half of 0 is still 0, and half of 2 is 1. 102 right there. Okay, and then because this is an area, it's going to be square units, because it didn't give us inches, centimeters, or anything like that. So we're just going to write square units. So our final answer should be 102 square units. Did Gage get 102 square units? Get rid of the keyboard. He sure did. So he was correct. All right. Group 1, our final review for the week was the area of circles, I believe. Yes, it was. All right. So the Gong and Mr. Roll's class room has a diameter of 21.5 inches. What is the area of the Gong? All right, so let's go over here, move that up. I'm not sure why it's not wanting me to move that up anymore, so we'll just erase that real quick. All right, so I forgot the numbers because of that. 21.5, all right. So to find the area of a circle, we need to do area equals pi r squared. All right. So we don't have the radius, nor do we have anything else that we know, but pi is one of those irrational numbers, so we're just going to replace it with 3.14 because that's the mathematics standard that everyone uses. So we're going to do A equals 3.14, and then we know our I'm sorry guys, I'm still recovering from being a little sick. We know our diameter is 21.5, right? So 21.5, and hopefully all of you remember that the radius of a circle is just half of the diameter. So half of 21.5 is 10.75? All right, 10.75. All right, so the diameter was 21.5, and half of that is 10.75. Okay, so that's our radius right here. All right, now for our equation, we need to square that. So what we're going to do is we're going to do 10.75 times 10.75. I'm sorry, my guys, or my fives look a little weird on this iPad. It's not very easy to draw with an Apple Pencil for me. All right, so let's see, we got 5, 2, 35, 7, 33, 8. There we go. 0, 3, 5, 35, 49, 52, 0, 5, 7, 5, 7, 0, 1. Okay, so we get 5, 12, 6, 5, 15, 1, 1. The 1, 2, 2. All right, 115.5625. All right. Now we need to multiply that by 3.14. Okay, so we're just gonna go ahead and go here, and we're gonna erase this line here and all this stuff up here just to make some room. And then we're gonna write 3.14 here, and we're gonna multiply these across, so we get 20. Yeah, sorry about that, guys. I was coughing. All right, 20, 8, 10, 4, 24, 25, 22, 22 again, 4, 6, and then 4, right? And then we got 5, 2, 6, 5, 5, 1, 1. Right, and then we get 15, 6, 7, what's that, 18, 15 with 1, 16, 16 again, and then we get 3 times 1 plus 1 is 4, and then a 3. All right, hold on, that 3 doesn't look quite right. There we go. Sorry, so just make it look better. All right. All right, so add all these together, we get 0, 5, 12, 8, 6, 16, 6, 16 again. Let's see here, 12, 18 here, plus 1, 12 here. That's a 6 and a 3. Okay, so we have quite a few decimals here to move. So 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. So right here. All right, so our final answer is 362.866250. And it was inches, I believe. Let me double check. Yeah, inches. All right. So get rid of the keyboard, pull up my pen again. So it's inches squared. All right. And that's how you would solve the area of the gong in Mr. Roll's classroom. All right. Well, there you go, guys. That's your quick, simple review of how to do your area of parallelograms, triangles, and circles. Stay safe, everyone. Stay healthy. And I hope that we get all through this soon and that we can all be back in class together. Have a good one. Bye-bye. Hello, Group 2. It's been a while since I've heard from many of you, and it's been an extra long time since many of you have heard from me. I was out the whole week before our whole school shut down, as many of you remember. I hope all of you are doing well, staying safe, staying healthy, and everything. Let's go ahead and get jumped into our review, though, for our week of math this week. And I believe your first lesson was systems and graphing. And it was. Alright, so our first problem, Zamarius is running a concession stand at a school basketball game. He is selling hot dogs and sodas. Each hot dog costs $2.25, and each soda costs 75 cents. There's a space right there, but that's fine. At the end of the game, Zam had made a total of 117.75. Right. He sold a total of 87 hot dogs and sodas combined. Is 35.52 a solution to the system? Okay. So what we're going to do over here, so we need to graph these, at least, well, we don't have to graph them, but because your lesson was over how to solve things graphically, we're going to do our classic slope-intercept form with these. So we had 2.25 for the hot dogs, so we're going to use D for hot dogs, and then it was 75 cents for soda, so we're going to put 0.75 S, and then he earned a total of 117.7. Oh, that's not a 7. Hold on 1 second. There we go. All right, so you earned a total of 117.75, and then our other equation was hot dogs plus sodas equal 87. All right, so all we have to do is solve these into a y equals mx plus b. We're just going to use s as our y and d as our x. So let's start with this first one here, and let's solve that for s. So let's rewrite it first. So we got 2.25d plus 0.75s equals 117.75. All right, so first thing we want to do is subtract 2.25d from both sides and draw the wall, because I know many of you will yell at me if I don't.
That's right.
All right, so let's move down a little bit here. All right, so we have 0.75s equals negative 2.25d plus 117.75. Now we need to divide by 0.75 to both sides, and we get s equals negative 3d plus 157? Yep, 157. Okay, so this is all we need for our first line here, because we can graph that on a graph. So let's go back up and do our other one. So we have d plus s equals 87. So d plus s equals 87. And we're just going to keep using our wall from earlier. Minus d on both sides. So we get s equals negative d plus 87. So right there. All right, so these are both in our slope-intercept form, or y equals mx plus b for some of you. So all we have to do is go plot these two lines on a graph, and I already went ahead and did that in the graphing calculator app that many of you are familiar for, just to show you guys, because let's be real, me drawing a graph on the iPad wouldn't look pretty. You guys know how much I like my graphs being nice and neat. So here we are with our graph. We have our nope, not there. Where is it? Is it this one? Yeah, there it is. Our blue line is the s equals negative d plus 87, and the green line is our s equals negative 3d plus 157. And if we look at this dot right here, right there, it says 3552. We can zoom in on that if you guys want to see it even better. Right here, 52 for s and 35 for d, or x and y in this case. Now, if we go back to our problem, what was it? 35 right here and 52. So those were correct solutions to the system. Again, you could have just done this by hand. You didn't have to graph it, but just to show you guys. So let's move on. Your next lesson was systems and how to solve them with substitution. So I know Aiden's going to be very upset with me for this next question, but that's fine. Got to mess with him somehow, even though he's not in here with the rest, like normal. So Aiden is playing the new Animal Crossing game. He is selling tarantulas at a rate of 8,000 bells each and oarfish at a rate of 9,000 bells each. He kept selling these two creatures until he earned 758,000 bells to pay off his loan with Tom Nook. He sold a total of 89 tarantulas and oarfish combined. How many tarantulas and how many oarfish did Aiden sell to pay off his loan? Okay, so let's go write those numbers down in our other thing. So we have 758,000. Those are other numbers that we needed. 8,000 and 9,000. Okay, so 8,000, 9,000, and then 89. All right, 89. All right, so we can get rid of that now. All right, so these are our numbers that we're going to be working with. So we know that he sold a total of 89 tarantulas and oarfish. Okay. So what we can do here is we're going to use T for tarantulas, and because O's and whatnot are a little confusing with zeros, instead of writing O for oarfish, we're just going to put F for fish. Okay, so T plus F equals 89. Okay, and then we have he needed a total of 758. Oh, that's not a 5. There we go. 758,000, and he was selling tarantulas at a rate of 8,000, so it's 8,000 T plus 9,000 F. All right. And these are our two equations that we're going to be working with right here. All right, so what we're going to do is we're going to start with this equation here, okay? And we're going to solve for, let's solve for F, all right? So what we're going to do is we're going to rewrite it first of all. So T plus F equals 89, okay? We're going to subtract T from both sides. Sorry, guys. With all the COVID-19 stuff, I've been having to keep a lot of extra food in my household for my pets, and it's messing with my allergies. Anyways, so we have F equals, that is, I don't know why I did that. Let's get rid of that extra line. Okay, F equals 89 minus T. Okay, so we have that. So what we can do is we can go back to this equation here. Okay, so let's write that equation again. So we have 8,000 T equals 9, or no, not equals 9,000, it's plus, that's not a very good plus, there we go, plus 9,000 F, okay, and then equals 758,000. All right, so we're just going to replace this F right here with this answer. Okay, so let's rewrite it one more time. So we have 8,000 T plus 9,000, and then in parentheses, 89 minus T equals 758,000. Okay, so now we're just going to solve it out like a normal algebraic equation, and we're going to solve for T because that's our only variable now. So first things first is we need to distribute this 9,000 to both these. Okay, so we have 8,000 T plus 9,000 times 89. That's going to be a large number, but that's okay. We get 9,000 times 89. We get 801,000. So 801,000 minus 9,000 T equals 758,000. Okay, so at this point, we just got these two like terms here and here that we can combine. So we're going to write it. Sorry about that, guys. We're going to rewrite it one more time. So we have 801,000 minus, not 9, negative 9 and normal 8 equate to just negative 1,000 here. T equals 758,000. All right. Now we can finally draw our wall here, and we can get started with solving for T. All right. Cool. All right. So the first things first is I like to work with positive variables. So instead of moving 800 and 1,000, we're going to move our 1,000 T by adding 1,000 T to both sides. So we got 800, 1,000 equals 758,000 plus 1,000 T. Again, sorry about that, guys. Got a lot of extra food for my reptiles at home, and they are not doing well with me and my allergies. All right, so our next step is to subtract 758,000 from both sides. Okay. Okay, and then we get, let's see here. That's 43,000? Yeah. 43,000 equals 1,000 T. All right. Now, our last step here is to divide by 1,000 to get T by itself. Okay. All right, so our final answer here is, what is this? Oh, that's stuff from group 1. Oops. All right. 43T. All right, so let's go back up to this equation right here. Okay, so we know that T is 43. Yeah. All right, so T. So T is 43, so we can write 43 plus F equals 89. Okay, so minus 43 and minus 43, F equals 46. Okay, so and we'll just rewrite it right here just to reaffirm it. So Aiden sold 43 tarantulas and 46 oarfish. Oh, I'm so sorry about that, guys. All right, let's say that one more time. So Aiden sold 43 tarantulas and 46 oarfish to pay off his loan to Tom Nook. All right, and our final equation here is elimination review. So Toby and Julio go get lunch together. Toby gets 2 soft tacos and a breakfast burrito, and his bill comes out to $12.35. Julio gets a soft taco and 3 breakfast burritos, and his total is $14.15. How much do soft tacos cost? How much do breakfast burritos cost? All right, so let's do this with the elimination method. All right, let's just scroll down past all this group. That's our earlier group 1 work. Huh. Weird. Alright, let's just go past that. Alright, so elimination method. So let's see. What numbers are we working with? I already forgot. That's group 1. It is 2T. Alright, so 2 soft tacos, 1 breakfast burrito, and it is 12:35. 12:35, and the other one is a soft taco, 3 breakfast burritos, and it is $14.15. So 3 breakfast burritos, $14.15. All right. So let's simplify these terms. So we're going to use T for tacos. So we have 2T. Actually, this is combination method, not so much elimination method. Oh well, it's still the same concept, so it's not going to be that bad. All right, so we have 2T plus 1 burrito equals 12.35, and T plus 3 burritos equal 14.15. Huh. Actually, this wouldn't really be the same thing for elimination. Alright, so for review for the elimination, let's forget that whole word problem and let's just pretend that this is a negative T. Okay, so that whole word problem doesn't mean anything anymore. Alright, so what we need to do is we need to combine these two equations, but we need to make it so that 2T here and the negative T here cancel each other out. So what we have to do, because 2T plus negative T don't equal 0, we need to times the negative T by 2. So we're going to times this whole equation here by 2. So we're going to have negative 2T plus 6B equals 28.30. Okay, so now we can combine this equation here with this equation here. Okay, so negative T, or negative 2T plus 2T is 0. And then we have 1B plus 6B equals 7B. Okay, and then we have 28.30 plus 12.35, and we get 5 here, 6 here, 0, 40. All right, 40.65. So this 0 doesn't matter anymore, so we can just erase that. Okay, and we don't need this plus anymore either, so we'll get rid of that too. Okay, so now we just have to divide by 7 to solve for B. Let's go ahead and full screen it. All right, so let's divide by 7. Both sides. I'll draw the wall because, again, many of you will yell at me if I don't do the wall, because you always do. So we get B equals, let's see here, what is that? It's a long, complicated number. I'll just go ahead and do 2 digits out. 3 digits past the decimal. So 5.807. All right. So 5.807. So we have a B solution here for our system. With that information, we can go ahead and go back into one of these two original equations here. Go back into one of these two original equations here, and we can just replace the B. And let's pick this one right here, this top one, because it only has one B, and that's nice and easy to work with. Okay, so let's replace it with B. So we have 2t equals, no, not equals, 2t plus 5.807 equals 12.35. 12.35. Alright, so now all we have to do is solve for t. Our first thing, draw a wall. Minus 5.807 on both sides. We get, what is that? Hold on, doing it in my head. Don't do this. Always write it out and just solve it normally, but 6.543, yeah. Alright, 6.543 equals 2t. Let's divide by 2 to solve for t. Okay, we got, let's see here, t equals 3.2715. All right. So our final answer, because, well, actually, I told you guys to forget about the word problem, didn't I? Shoot. All right. So our final answer for this, just because we forgot the word problem, is t equals 3.2715, and then b equals 5.807. All right, so there's your review on the elimination method. Remember, when you go to combine them, your two original problems, like right here, actually let's use our highlighter. These two original problems, okay. When you go to combine those, make sure that a variable that you're going to cross out, so in this case the t, because we have a positive and a negative, make sure that when you add them together that they do confirmed cross out 2, 0. Okay, it's very important that they go 2, 0, and then you can solve. And yeah, all right. So that's that, everyone. I hope you're all staying healthy, staying safe, and I hope that we can all be back together soon. Have a good one.